Two men are pulling on ropes attached around the neck of a mule that does not want to move. One man pulls with a force of 55 pounds, while the other pulls with a force of 75 pounds. If the angle between the ropes is 25 degrees, then how much force must the mule use in order to stay put? So let's draw a picture. We've got one guy pulling with a force of 55 and another with a force of 75, and the angle between those forces is 25 degrees. Okay, so the two forces would be added together, so let's actually take the 55 and we're going to put the 75 on the end of that. And if the mule had no resistance, the forces, the resultant force is right here. That's what we want to find, because if the mule's not going to go anywhere, he's got to apply that much force in that opposite direction, but we can find out what that magnitude of that force needs to be. So let's go ahead and label. We know this side is 75 because that's the 75 vector, just moved over to the tip of the 55. So we've formed a triangle there, and we have two sides of the triangle, but we don't have an angle in the triangle. We do have an angle. This angle is 25 degrees between those two. So how can I use that to find an angle in the triangle? Well, look at the two 75 pound vectors, and they are parallel. The 25 degrees is inside of that parallel line, and so this angle up here, this obtuse angle that's actually in the triangle, would have to be supplementary to the 25. So they got to add up to 180. So this has got to be 155 degrees. Now I have side angle side, so I can use the law of cosines to find that x. So one of the sides squared equals the sum of the squares of the other two sides, so 55 squared plus 75 squared, minus 2 times the product of those two sides, so 55 times 75, times the cosine of the angle between those two sides, and that was the 155 degrees. So now it's just a matter of a calculator. Make sure that, remember, that is x squared, so hit your square root button and then put all of this in. And we're going to round to the nearest pound. So that will be 127 pounds. That's how much the mule's got to be able to pull back if he doesn't want to go anywhere.